So this is a couple problems that are on your lesson 5.6 worksheet. We're going to start with number 1, and I'm going to do about half of it with you. Okay, so number 1, on the front page, we're just finding the inverses. So I outlined the 3 steps for you to do that yesterday, right? Do you guys remember what step 1 was? Change the f of x to a y. So f of x becomes y equals x minus 1 to the 5th plus 2. All I did was I changed that f of x to a y. That's my step 1. What's step 2? Change what? Yep, we're going to switch positions of the x and the y. Okay, so y becomes x becomes y. They just swap spots. Did anything else change in the equation other than the x's and the y's switch positions? Nope. So then we're on step 3. What's our step 3? We're going to solve our equation for y. So I'm going to rewrite my equation here. We are going to solve for y. So what should I do first to get y by itself? Do you agree y is kind of closed off? Okay, so, yep, let's get rid of this 2 first. So I'm going to subtract 2 on both sides. So we have x minus 2 equals y minus 1 to the 5th. Okay, how can I open up those parentheses? What would I do if this was a squared here? I would take the square root, right? We're going to do the same thing, but I'm going to take the 5th root. Same thing. So what I do to one side, do to the other. So now I have the 5th root of x minus 2 over here, just like the square roots. These cancel, so I'm left with y minus 1. And then what's my last step to get that y by itself? Yep, add 1 to both sides. Does that 1 go inside the radical or on the outside? It does go on the outside, yep. So we have the 5th root of x minus 2 plus 1, I'll write it over here, equals y, or y equals that. Again, it doesn't matter how you write that. Okay, so I know I'm done because I have y by itself. Okay, usually once you get y by itself, there's not going to be any more simplifying that needs to be done on the other side. Okay, your main goal is just to get y by itself first. All right, so same thing on number 4. We want to follow our 3 steps to find the inverse. I'm going to outline them again. What's our step 1? Change that g of x to a y. Remember, doesn't matter what, I'm going to say letter or function this is. Nope. It can always change to y. So y equals negative 16 minus x over 4. What's my step 2? Yep, x and y switch spots. Again, nothing else changed. Now, I'm on to my step 3, which is we're going to solve for y. Yep, I'm going to rewrite my equation here. You guys don't have to do that. How do I solve for y here? Do we like fractions? Go for it. What do you mean equal to 4? Yep, we want to multiply both sides by 4. Whenever we have fractions, multiply by whatever this bottom number is to get rid of it. So this turns into 4x equals, well, these 4's cancel, so I'm just left with what's on the top, which is negative 16 minus y. So now, how do I get y by itself? We want to get y by itself. I know we're used to getting x by itself, but make sure you remember we're getting y by itself. So I heard it. We need to add 16. So we have 4x plus 16 equals negative y. Is y completely by itself yet? No, because what's this negative?
1.
That's a negative 1, right? So how do I get rid of that negative 1? A lot of us would think add, which is valid, okay? But what is happening between the negative 1's and y's? They're multiplying. Yep, so we got to do the opposite. So we want to divide by a negative 1 on both sides. What does dividing by a negative 1 do? Close. This negative, it's going to change our signs. So it's going to turn to a negative 4x minus 16. And then again, how do I know I'm done? Y is by itself.
Are we writing the 3 steps for the back page?
So, last one I'm going to do with you on the front page, number 5. Again, we're still finding inverses. So what is my step 1? Yep, change g of x to a y, so y equals the cube root of negative x plus 1. And then my step 2, switch positions. Does anything else change? Nope. Everything else stays the same. And now I'm on to step 3, which is we're going to solve for y. Do you agree y again is kind of closed off? How can I open that up? We're going to cube it. Yep, you want to do whatever that root number is. So what I do to one side, do to the other. So I have x cubed equals, this side cancels, so I'm left with the inside, negative y plus 1. And now remember our goal is to get what by itself? Y. So what do I do next? Subtract 1. X cubed minus 1 equals negative y. And then from here? Yep, we got to get that negative 1 out of there. So I'm going to divide by negative 1. Again, what does that do dividing by negative 1? Switches the signs. Yep. So we have negative x cubed plus 1. And I'm done because y is all by itself. Now, on the back, we are stating if they are actually inverses. So this time, they give me 2 equations. In order to verify that they're inverses, we want to find their compositions and making sure their compositions are the same. Again, what I mean by composition is I want to find f of g of x. That's a composition, one of another. Okay, so let's just do this one first. Again, we work inside out. So do I know what g of x is? Yep. So what is g of x? Yep. So I'm going to take this right here and I'm going to substitute that in for my g of x. So I have negative x cubed minus 2. Now look at what we have left. What do I do with this negative x cubed minus 2? Plug it in for which one? We're going to plug it in for f. Good. So I'm going to plug it into this x right here. Be careful with that negative. So if I rewrite this, I have the cube root of this negative here is still there. So now I'm substituting. I have negative x cubed minus 2. And then don't forget I still have that plus 1 in the inside. So again, remember when you get to this point, after you plugged it in, all you have to do is just simplify this side. We're not getting anything by itself, we're just simplifying. So what can I simplify looking on the inside here? Yeah, the parentheses, right? What do I do with this negative 1 outside? Distribute, yep. So I have the cube root of, if I distribute that, I have x cubed plus 2 plus 1. And then is there anything else I can do here? Combine like terms, right? Correct. It would turn into x cubed plus 2 plus 1 is 3. And then remember, you just simplify as far as you can, okay? Do you agree I'm done simplifying here? Can't go any further? All I want you to do right there is underline it. That's our first part. Okay, now, we have to see, I'm going to draw a little line to separate us here. We have to see if the other composition matches that to know if they're inverses. Okay, so what's the opposite of f of g of x? G of f of x. Yep, we're just going to flip-flop spots here. Okay, so same idea, but now we're going to find g of f of x. So again, work inside out. Do I know what f of x is? Yep, so we're going to plug f of x into there. F of x is the cube root of negative x plus 1. So once I have that, what do I do from here? Yep, I'm going to plug this into my g function where I have that x. Being careful, I have that negative there. Okay, so I have negative times the cube root of negative x plus 1. All of that is to the third power because of this right here. And then I still have that minus 2. From here, remember we're just simplifying. What do you notice happens? That's kind of nice. Right, these are going to be gone, but be careful, we still have that negative outside, so I got to be a little careful with that. We have negative times negative x plus 1 minus 2. What do I do next? I got to distribute that negative 1 in, right? So this turns into positive x minus 1 minus 2. Which is, what do I do from here? Combine like terms, -1 minus 2. -3. Do you agree I'm done simplifying? Okay. So now I have both. Now we compare. Are they the same? No, they are two completely different functions there. So what's our answer? Our answer is NO. No. That means they are not inverses. Last one I'm going to do with you here is number 10. Okay, same thing. We are determining if these two functions right here are inverses of each other. So to determine if they're inverses, what do we have to compare? We have to compare the compositions. Give me a composition. How can I write these two as a composition? What'd you say? I can do f of g of x. Yep. Let's start there. So if I start with f of g of x, same thing we were just doing, start from the inside. Do I know what g of x is? Yep, so let's plug that in. Okay. What do I do when I get to this point? What do I do with this 7x plus 2? Plug it in for, yep, the x and the f functions. So this turns into 7x plus 2. Do you agree I still have this minus 2? Okay, so this minus 2 over 7. Okay. So again, now we're just simplifying. Look at the numerator. What happens? Can I combine like terms? 2 minus 2 is? You agree they're gone, right? Okay, so I'm left with 7x over 7. What else can I do? 7s can cancel, so I'm just left with x. That's a good sign. So now we need to do the opposite. What's the opposite of f of g of x? G of f of x. Yep. So working inside out, do I know what f of x is? Yep, it's g of, what is f of x? X minus 2 over 7. What do I do with that x minus 2 over 7? Plug it in for that g function. Yep. So what this turns into is 7 times x minus 2 over 7 plus 2. So now let's simplify here. What happens? Remember, treat this kind of as over 1. What's going to happen here? We would distribute, you're correct, but what else can happen? 7s cancel, yep. These 7s are gone, so I'm left with x minus 2 plus 2. So then combine like terms, what happens? Yep, negative 2 plus 2 is 0, so I'm just left with x. What's that tell us? Yep, because they are the exact same. They lead to the same answer, so our answer is yes.